Ray, if you could just click forward one slide and then go back to make sure the recording starts on the screen. I read about a glitch in GoToMeeting where sometimes it doesn't start if your screen is already set. So if you could just move forward one and then go back, and then we can get started.
Okay. Well, I'll just stay. Do I have to go back? Let me see.
It would make me more comfortable if you went back.
Okay, I'm
Perfect.
back.
Okay, I think we are all set to go then.
Okay. All right. Tony, did you just want me to get into it? Did you want to say any introductory remarks before I begin, or should I just run with it?
No, I think let's just run with it. I think, I appreciate everyone being here. I think our purposes were clear, and I appreciate those that have joined today's call. And I'd rather just get into the purpose for being here today. So thank you, Ray.
Okay, sure thing. So thanks, Tony, and thanks everyone for attending this session today. And I really do appreciate you taking the time out. What our agenda for today is going to be is, I'm just going to quickly go over the background behind the Abstract Modeling Task Force and where it's coming from and where we want to go with it. And then the real meat of the discussion is a walkthrough of the UML model as we have it today. And then following that, I wouldn't mind getting some feedback and also some opinions from the audience as to what you think of the current modeling effort and also where we could possibly go with it, because there are several options on the table at this point, and the XSV has not yet made any specific decisions as to what the next modeling effort needs to be, but I can talk about some of the options that certainly are on the table in that regard. So, so first off, just give everyone in the audience a quick rundown in terms of where the Abstract Modeling Task Force has come from. So about a year ago, XBRL International released the technical strategic plan document, which we've termed the P3 document. It's called the P3 document because the title of it was Preserve, Promote, Participate. And in that document, there were 6 key technical initiatives that were identified. And by and large, the one initiative that stood out as being the most important and the one that would bring the greatest benefit to XBRL International was indeed the abstract modeling effort. And hence, in the fall of 2010, in fact, at the Beijing conference in 2010, it was announced that XBRL International would be forming the Abstract Modeling Task Force. And in that time frame, the overall response from the market was extremely positive. We had a survey set up on SurveyMonkey for individuals who wanted to participate in one or more of the 6 initiatives that had been identified by the XSB. And the abstract modeling effort was easily the runaway favorite, if you want to call it that. It was the one that the most people signed up for, and it was really consistent with the feedback that we had received earlier in the year in terms of what the marketplace was telling us that we needed. And they were telling us that we needed to provide an abstract model for XBRL. So building on that momentum and building on the announcement that was made in Beijing of 2010, we did a pretty targeted or large outreach effort to individuals and to also other organizations to see who would be interested in coming to the table. And that led to the formation of the task force in January 2010. And what's really noteworthy about this is that a lot of individuals who signed up for the task force had not been involved with XBRL before. So it was an indication that these initiatives were indeed bringing in a lot of new interest that previously had not really been involved in XBRL to that extent. And hence, it was a good indication to us that it seemed that we had identified a good suite of initiatives, and the abstract modeling was definitely a good confirmation of that. So we formed the task force, and in the formation of the task force, one of the things that we had to state pretty explicitly, obviously, was what the objective of the task force was going to be. And leading up to the individual signing up to it, we basically came up with the phrase that what we were going to be defining was the meta model for XBRL. So for those that are involved heavily in modeling, I think the term meta model has a specific meaning, and it does it does describe the effort quite well, because what we are bringing together is the meta model for XBRL. So in other words, what we are modeling is XBRL itself, so XBRL, the specification, and not necessarily how XBRL has been applied in specific projects or in specific jurisdictions and domains. And one of the things that was pretty clear from the get-go was that whatever we put into the meta model for XBRL had to be universally applicable. So we had to avoid anything that was domain specific, and any evolution of how XBRL has been applied, and that was specific perhaps to a particular project. We had to make sure that that was not influencing or tainting the model in any way. And so that was one of the things that we knew we had to do. The other objective that we kind of try to communicate was really the separation of the semantics of XBRL from its syntax. And that's actually a pretty significant undertaking when you think about it. We have in our hands a fairly large specification, which actually combines both the semantics of XBRL and the syntax of XBRL into a single specification. And we essentially went into the effort with the understanding that we were going to try to bring a pretty clean separation between what is purely syntactical in nature. So in other words, what is in there due to the fact that we're using XML, what's in there due to the fact that we're using XLink and schema and so forth, versus what is really the intrinsic information model of XBRL. So those are the sort of the high-level objectives that sort of form the basis of the task force coming together. And almost from the first day that the task force came together, it was pretty clear that in order to deliver on this semantics separation from the syntax, that this meta model would have to be delivered in two distinct phases. And we ended up calling it the primary model versus the secondary model. And the primary model is the one that's going to be under review today, and that's the one that focuses on the semantics of XBRL. And then following that, there would be the need for a secondary model, which is really the binding of the semantics onto today's XBRL syntax. So the whole thought of that is that once you have a primary model for XBRL, it's theoretically possible to bind that to any technology. For example, if you wanted to bind it to SQL, for example, you could do that. If you wanted to bind it to a specific programming language implementation, you could do that as well. And for us, we identified that obviously in order to really fill the gap between what most people associate with XBRL and the semantic model that we were coming out with, it was pretty important that we also deliver on the secondary model, which basically bridge the gap between the semantics and the syntax. That being said, the AMTF recognized that still the prime directive is the delivery of the primary model, and hence, even though we have actually gone through quite an extensive exercise in building out the secondary model, and that was sort of a necessary prerequisite to us to get to a point where we could actually abstract things and deliver on the primary model. There is some semblance of a secondary model there, but we are not emphasizing the secondary model at all. We're not, in fact, seeking any public opinion or feedback on the secondary model at this point. It really is only the primary model that we are seeking feedback on at this stage. I'll just pause there quickly if there's any questions in terms of where the AMTF has come from and what its overall objectives have been. Okay. So just a quick timeline to sort of understand, help you understand what the effort has entailed so far. The task force was formed in January of 2011, and we met for a face-to-face meeting in Boston in January, where we focused specifically on the XBRL 2.1 specification. We left that meeting having made significant progress. Dave Frankel, who will be joining the call later on, is one of the UML experts that had signed up onto the task force, and he did a really thorough and almost exhaustive job in challenging a lot of the assumptions that we had made around XBRL and really in terms of understanding where XBRL was coming from, I think that was a really productive meeting in terms of being able to come up with at least the beginnings of the primary model for XBRL 2.1. We then followed up that meeting with another face-to-face in Washington, where the focus was specifically on dimensions 1.0. And following those two face-to-face meetings, we had in our hands roughly 75 to 80% of the model that I'm about to show you today. And following those two face-to-face meetings, most of the effort centered around polishing up some of the looser or rougher edges and cleaning up some of the really open action items that really needed still to be looked after in order for us to release an internal working draft that was announced at Brussels earlier this year. And starting with Brussels of this year, we basically started a feedback cycle where we were seeking feedback from members from XBRL International to sort of help us understand if the model was going in the right direction and if the assumptions that we were making were consistent with what members thought an abstract model of XBRL should look like. And this webinar is really part of that feedback cycle, and it certainly is very valuable input into our overall process. The hope is that by Montreal of this year in October, that we will have the model at a PWD stage, and we hope to make that announcement in several weeks' time. We're at this stage putting in the documentation for it, which will help, which will go a long way in terms of helping to document and explain the model as we deliver it. Okay, so that's it for the background behind the AMTF and what this effort has entailed and sort of how we got to where we are today. I'm now going to dive into the various diagrams that we've come together for the abstract model. Now, part of the announcement or part of the invitation for today's meeting, there was a link that was sent out, and in that link is access to the internal working draft that we released back around the Brussels timeframe. So hopefully you've had a chance to look over those diagrams. What I'm about to review right now is our different snapshots of the diagram, and which I've included in this slide, and I'll sort of focus our discussion on different parts of the model one at a time and sort of explain how all these different pieces fit together. So the abstract model has been divided into 4 high-level packages, and hopefully it's coming through where what we've tried to do is have a color-coded theme run throughout the model. The 4 packages are the instance model, which has a sub-package that we've called the fact model. There's also a concept model, which is colored green throughout our model, and then there's also a purple typing model, which sort of captures all of the XBRL types that have been identified. Now, the way that these packages have been organized, you'll notice that there's a dashed arrow that runs from one package to the next, flowing in a left to right direction. And what that indicates is that these various packages are sort of built on top of one another. So if you look at the typing model as being the bottom layer, on top of that, the concept model is provided, and then on top of the concept model, you actually have an instance model and the subpackage of that being the fact model. So this is a very high-level package organization of the abstract model. And what's interesting about the way that we're packaging these things up is that one of the other initiatives that came out from the P3 document was an initiative to reorganize the specification. So this could possibly serve as an input into that particular initiative once it gets started. And this is one of the reasons why we felt that the abstract model was indeed the one initiative that had a lot of dependencies on it, is because once you start looking at the model and seeing how things are organized, there's a lot of different dependencies that end up being dependent on the model, and this is an example of one where the way that we've organized the packages could later on influence how the reorganization of the specification actually takes place. Okay, so there's not a whole lot of detail at the package level. It's just sort of a quick introduction to the colors that we've used, and also how we've broken things down in terms of what all the different pieces are and how they end up being organized into packages. So on the next slide, I'd like to introduce the class that we've called Extensible Element, and this is the beginning of our model, and this serves as an introduction to sort of how we've used UML and really the color coding runs throughout in this. You'll notice that the instance model for example, all those classes are in yellow, and all the concept model classes are in green. And the reason why we inserted this class into the model, Extensible Element is in there because of the fact that we found that a lot of elements or a lot of classes in XBRL have this ability where users can come along and introduce custom attributes in XML parlance. In our definition, we've called them user-defined properties. And what user-defined properties really are is just a simple name-value pair. And this ran as a common theme throughout many of the classes in the XBRL meta model, which is that the 6 classes that you see there are actually quite extensible in the sense that a user could come along and add additional properties to them as they saw fit. Now, what may also be a subtle point in the way that UML is used is the fact that italics is significant. So you'll notice that of the 6 classes that are identified there, 3 of them, in fact, are italicized: the fact, meta class, the concept, and also the relationship. So what this indicates is that whereas there's really only 6 classes on this diagram that shows the ability for being extensible, that there's actually a lot of other deriving classes, classes that derive off of concept, for example, and classes that derive off of relationship, which also inherit that ability for extensibility. So we didn't put all of those classes in here because we wanted to keep this particular diagram lean and simple. But nonetheless, this diagram introduces the fact that a lot of meta classes in our model have this ability for extensibility, where you can add name-value pairs to that particular meta class. Okay, I think as a matter of procedure, I'll make sure that I pause briefly at the end of each diagram to make sure if there's questions or comments about what I've just shown, that we can take them. So I'll just take any questions at this point about the extensible element, if there are any.
Yes, one very quick question, Ray. You mentioned that italics means that there are additional classes that are extending that, but does it mean that the class is abstract?
Oh yes, that's right. So to be perfectly correct, what it means is that it's an abstract class, and abstract classes in our model serve as a base. And so more often than not, and I think in practically every case where we have an abstract class, we do have deriving classes that derive off of that. So
hello, this is we're just looking for a moment to say that I'm here, David Frankel.
Oh, hi there. Hi, is that Dave? Is that you dialing in?
Yes, that's me. Oh,
hi, Dave. Hi, welcome, Dave. Thanks for taking the time out of your OMG meeting to attend the call, Dave. Your presence is highly valued, and we do thank you for coming to the call. I just finished stepping through the model or the background for the AMTF, and just began stepping through the model here with Extensible Element. And I was just explaining how in UML italics is used to indicate an abstract base class, and in our model, abstract base classes are almost always derived from. So in other words, there's another concrete class that derives off of that. And so just to sort of explain the subtlety on this particular diagram, there's only 6 classes that are pictured, but there's a whole lot more other classes underneath these 6 that actually inherit the ability for extensibility.
Yeah, an abstract class cannot be instantiated. You can't create instances. You can only create instances of subclasses. It means the same thing. Abstract means the same thing in UML that it means in Java, for example. It's basically the same.
Okay, thanks for that, Victor. Does that answer your question, Victor?
Yes, absolutely.
Great. Okay, thank you. Okay, so the order in which I'm going to go through the model is basically from left to right in terms of the earlier package diagram that I showed earlier. And the model, now I'm not sure if everybody's actually seen it as a whole. So what I'll do is, this is the magic draw tool that we have, that we've been using for the task force. And as you can see, this is what the instance model, the entire diagram for it looks like. And if you've accessed that link prior to today's discussion, you might have seen this already. But if not, I wanted to show the diagram as a whole before I started focusing on different portions of it. So the first part I wanted to focus attention on in the instance model was really the heart of this particular snippet that I've taken is an abstract base class that we've called fact. And so this is an example where, fact serving as an abstract class is actually the base class for 2 other classes in our model. One is the structured fact, and the other is the item fact. And for those of you that are familiar with XBRL, you'll no doubt recognize that this really is just tuples and items. So we have avoided the terminology of tuples in our model, and we've actually settled on calling, wherever we use tuples, we've called it structured fact or structured relationship, simply because we wanted to remove that specific terminology from our model. Now, when we bind this to the secondary model, which is a much more syntax-oriented model, we obviously will have a much closer representation to the actual syntax, and it's quite likely that those classes will then be a little bit more familiar. But at the primary level, we wanted to sort of bring about a distinction between what we were modeling at the primary level, and hence we've avoided the term tuple and settled on the terminology for structured fact. Now, the other thing that the one other thing to note about fact at the abstract level is that there's a footnote associated with it, and footnote has content. And I think this is a good example of the abstractions that we are bringing into XBRL at the primary level, because those of you that are, again, familiar with XBRL instance documents know that how footnotes are actually bound to facts. They use the whole X-link mechanism, and the syntax for actually creating a footnote that is associated with a fact can actually become can become a little bit messy. But in our model, we have a single association from fact to footnote, and that's an example where we think we're bringing simplicity to the abstract model, and we're definitely abstracting things a lot higher than what they actually are in the specific XBRL syntax. Now, what I wasn't able to really communicate in this little snippet that I took was the fact that, I should probably avoid that word, was this relationship here is how a fact in our model through this association is associated with a single concept. And what this tells us is that, you remember those arrows that flowed from the left to the right earlier when I talked about the package diagram? This is an example of how that arrow is manifested, in that this fact here has a dependency on the concept class that, again, because it's green, is in our concept model. But that's an important association, because a fact by itself may not have a whole lot of information related to it, but the minute you bind it to a concept, obviously that's where a lot of the meta information for a fact comes from. So so I wanted to bring that out, and I also wanted to bring it out because this was one of the more interesting points of feedback that we got when we exposed the model in Brussels, was really, does this association belong at this level, or do we have to push it down into fact properties? So before I get into that, fact properties is what I'm about to talk about next. So before I get into that, are there any questions about how we've abstracted the instance model and how the fact base class plays a pretty significant role in this snippet of the model? Okay, so I'll move into the next part then, which is this snippet that I've taken here. So item fact is on the very left-hand side, and this is the class that derives off of the abstract base class called fact. Now, item fact has a lot of well, there's a derived property inside of item fact. So if you look at item fact, and the one of the properties that have been identified for it is there's a slash fact properties. The slash in UML terminology indicates that it's a derived property, and what that means is that it's a property that can be inferred through OCL in the model. And what the fact properties is saying is that all item facts in our model have at least 2 or more fact properties, and the 2 or more, the 2 is the period and the entity. So every item fact comes with at least 1 period and 1 entity, and there could be other fact properties as well. So on the right-hand side, there's an abstract base class that we've introduced that we've called fact property. I think in our discussions with the feedback that we've been receiving thus far, I think another alias for fact property is aspect. So for those of you that are familiar with the aspect work that is going on in XBRL formulas, you could almost insert aspect in here as being the equivalent of fact property. And what fact property is an abstract base class from which classes like period derive, entity also derives off of that, and then we've also added scenario as a deriving class off of fact property, and likewise dimension. So dimension is obviously is the class that we're using to indicate how item facts can be further contextualized through a dimension and a member of that dimension. So, so these are the 4 fact properties that we've identified in our meta model, and again, if you wanted to call the fact properties aspects, that would fit into this particular model as well. And so, going back to the earlier point that I raised with regards to this line here, this association here, a lot of the debate has been whether or not this particular association should be as you see it in the model right now, or should we push it down and insert it as a fact property. And I believe that's also one of the key questions that we had identified as needing feedback from the audience today, is if you could take this picture away and think about how the model is communicating the fact to concept relationship as it does today versus how it could possibly be communicated through a fact property. We would like to hear your feedback on that particular issue and sort of get a sense of where we think the XBRL community believes that the fact to concept relationship really deserves to go. Are there any comments on that particular point at this time?
Can you explain in a bit more detail, if you're coming on to this, a bit more how dimensions work under this model?
Sure. So this, keep in mind, this is only the instance model at this point, and I'll talk a little bit more about dimensions once we get into the concept model. But in an instance document, so I'll go to the full class diagram here so that I can navigate between the instance model and concept model. Facts in an instance document can be further contextualized, obviously, through specific occurrences of a dimension and a member in that dimension. And so that's what this line here, this association is meant to convey, is that facts can have 0 to many dimensions associated with it. Now, what is important about this association, and again, this is another example of how we've abstracted things, is that in XBRL instance documents, there's discussion, should the dimension occur in the scenario element or should it occur in the segment element and so forth. The task force specifically identified that as being a syntactical debate and not something that really needed to be pushed into the primary model, and hence the way that dimensions work on the instance side of things, at least, is that there's a direct association between a given item fact, and that's why there's a 1 on this side, and a given item fact may have anywhere from 0 to n number of dimensions associated with it. Now, that dimension has also this is the other part of the model where there's an association going from the yellow to the green. And this association, very similar to this association up here, means that when a dimension does occur in the instance document, there is further meta information about that dimension through a class in our concept model that we've called Axis. And I'll be going into the concept model a little bit more in depth later on, but at least on the instance level, this is how things work. Does that satisfy your question in terms of how dimensions work at the instance level, at least?
Yeah, I had a couple of follow-on questions, which is, where does the dimension value get stored, and are you storing, does the model include defaulted dimensions?
The model, so default dimensions is not something that the model includes right now. Potentially that's something that we could insert. The value for the dimension, so it was pointed out maybe about a month after Brussels that was indeed a missing part of this model at this point. We had captured it at the secondary level where an item fact would have a dimension, and then the dimension itself would also have another class that was associated with it that would actually be its member. In our editing of the primary model in preparation for Brussels, we had actually left that class behind at the secondary level, and we need to push it back into this model when we deliver it to Montreal. So we recognize that as an open issue, and we will be cleaning that up as part of our preparations for Montreal.
Okay, thank you.
All right, thanks, Paul.
Yes, one question. What is the content of the fact stored? What is the value of?
Okay, so that's a really good question, because that brings me into the next part of the discussion. Thanks, Victor. Which is the fact model. You might remember earlier when I talked about the packages that there was we broke down the instance model into the instance model and the fact model. So, in answer to your question, where do the values go? The item fact is itself a base class for other fact classes as well. And so in our fact model, this is where we start to break down all of the different types of facts that can actually occur. So moving from the top down, you have item fact, and then on the left-hand side, you either have a non-numeric fact or you have a numeric fact. And the distinction between the non-numeric fact and the numeric fact is that numeric facts come with units, and that's a significant property that's introduced at that level. On the left-hand side, with the non-numeric facts, there's all sorts of non-numeric facts that one could have. Obviously, you can have string-based facts. In this little snippet that I've taken here, we've also introduced date facts, for example, and time facts. There's also another fact that's a date-time fact, so the combination of both the date and the time. And Victor, in answer to your question, you can see that date fact and time fact, they all have values in them. So we don't introduce values until we actually get to these pretty concrete classes, and that's because the value inside of the fact class itself, in and of itself, also has a type as well. So for example, in the date fact, the value, there's a colon after that, and then it reads date square bracket 1 square bracket. In UML terminology, what that means is that the name of the property is value, and then after the colon, the type of it is date, and then after that is how many occurrences there are of that. So there's one value that is of type date, and you can see that the type changes as you go from fact class to fact class, and that's why we introduce it's not until you actually get down to this level of class hierarchy, that you actually start seeing the values. Moving on to the right-hand side, off of numeric fact, we then make a distinction between fractional and non-fractional numeric facts, and obviously in a fractional fact, you'll have a numerator and a denominator, whereas in a non-fractional fact, you don't have those two properties. And what's also interesting about the non-fractional numeric fact is the introduction of precision and decimals, which in our model is added at this layer here. So this is just a snippet, again, of the actual model. If I went back to Magic Draw, this is the fact model in its entirety. And I mentioned string-oriented facts on the left-hand side here. That was another class that was inadvertently left out when we delivered the abstract model for Brussels. So again, that's another action item that we're aware of, that we need to insert that class back into this diagram here. But further on down, where my little screenshot kind of got cut off, you can see that these are all of the non-fractional numeric facts that we've identified, and they all have values down here. So hopefully, yeah, that answers your question as to where the values are coming from.
Ray, excuse me. Is it possible to make your screen just a little bit larger?
I can't increase the resolution, but what I can do is I can increase the zoom level of the diagram, and that might make this read a little bit nicer.
Okay.
Ray,
another question. Have you considered? I'm sorry. Have you considered the idea of representing in the fact model open context in the segment of a scenario? I mean, there are still some projects that are not using dimensions, but are using segment as a scenario to include some additional information.
Interesting. Yeah. In our instance model right now, and we recognize this as another to-do item for Montreal, there are these properties which don't have any type associated with them, and it's sort of like they're almost sort of like placeholder properties right now, just meant to communicate that we have talked about how a segment and a scenario has this quote-unquote content property, which is extremely loosely defined in XBRL. There's no content model defined at all for what can go inside of a segment or what can go inside of a scenario. And hence, we have not satisfactorily addressed what to call the type for content. But nonetheless, there is a property on segment and a property on scenario, which is intended to be a placeholder for additional information that that one might want to insert inside of those particular elements.
Ray,
and there's a very similar one. There are some projects that are using some. I'm sorry. Yeah, very quickly. There are some projects using specific attributes also to include information in instance documents.
Okay.
So maybe that, I mean, it's another tricky thing, but maybe something to consider or something to explicitly take away from the model.
Well, yeah. What we'd have to do there is whatever type we end up calling content, it would have to be very, very flexible. In that we want to obviously capture how projects are using those specific elements, and the challenge is coming up with the type definition for content and having it expressive enough and flexible enough to accommodate all the different ways that they are being used in projects. So so having those projects as real life examples, I think could be beneficial to help us shape what that content, what that type needs to be, and how it needs to look like. Thanks, Victor. Was there another question?
Yes, thank you. This is Paul Sappington. I had a question about the precision and the decimals. Do you have some modeling in here for the infinite setting?
Infinite, yes, we do. I'd have to, I'd have to dive into the secondary model to show where that was. Infinite, no, actually, do we? Paul, that's a good question. Let me come back to you on that, because I know we had talked about infinite, and right now it looks like we only have value where it's non-negative integer and integer, and obviously infinite is an explicit type in and of itself.
What we had said, and it's difficult to represent infinite directly in the UML model. So what we said was, if you look at the definition of decimals, is an instance of decimal with an empty value means infinite. Which is just a convention that's hard to model more explicitly. The XBRL has its own syntactical way of expressing infinite. This is, given what we can express in UML, the best we've come up with so far. There's no specific representation for infinite.
I see.
There is the notion of something that is unbounded, you know, in terms of its cardinality, that's not the same thing.
Yeah.
Right. On kind of a similar question then is about the nil property for the fact itself, the absence of a value.
Oh, right. Yeah. So I believe, so Dave, you'll have to correct me, but all of the values that we are showing on here, if we have a 1 after it, that means it's non-nillable. Is that correct, Dave?
Yeah, that means one. That means really 1 is in UML shorthand for 1-to-1.
Right.
It means lower bound of the cardinality is 1, upper bound of the cardinality is 1. It means exactly 1. Now, if those need to be, if you need to be able to state one of these facts and have it be, but have the value be empty, then we would have to change that to 0 to 1.
That's right. Yeah. Yeah. So good catch, Paul. What we'll do is we'll modify all of the facts, the value properties, so that they're actually 0 to 0.1, and that'll capture the nillable aspect that you referred to.
I don't know if I'm being heard. This is Herman Fisher. In the case of XML Lang on string properties, we just discussed this on the base spec call today. Certainly any text valued properties can have multiple values by simply having multiple Lang attributes, and that's still one semantic fact with multiple values, distinguished by XML Lang.
Right.
So that would have to be like a 0 to many. The value on the string type probably would be 0 to many. Cardinality is probably 0 to many.
Yeah. Okay. Okay. Thanks for that, Herm.
I think it is the same case as a custom attribute. That fact.
Yeah, you could certainly do it that way, because that's in fact how it is being done in the XML, right? Is that you have an XML Lang property, and that would essentially be your user-defined property. So in that case, it would still be the value would still be a single fact. But I think that's something that we still need to at least consider, anyways. Are there cases like that where a fact might semantically have multiple values associated with it?
And just to be sure that with regard to this issue of the nullable, being nullable, the fact itself being nullable, just to make sure we're not dealing with just not replicating a syntactic idiosyncrasy. What does it mean to assert a fact and have an empty value? What does that mean as opposed to, does it mean something different than not asserting the fact at all?
Yeah, the nil attribute means something quite different than having a fact with, let's say, an empty string value. It means that somebody explicitly reported that they do not have a value for this period.
Okay.
It is a semantic distinction.
Okay.
But those semantics are not defined by the XBRL specification. I think actually this is an annoying historical anomaly that we have such a wide use of the nillable attribute, which is that many taxonomies have a nillable attribute set, but only some environments actually ascribe a meaning to reporting something with a nil value. So in the case of string types, you've typically got 3 ways of saying nothing. You can leave the element out altogether, you can report it with nil, and you can report it with an empty string. And similarly for numerics, you can have not reported nil or 0. And lots of taxonomies have allowed the use of the nillable attribute, but haven't actually explained where it fits in between not reported and 0.
But I think the important point is we have allowed end users to treat that as a semantically significant issue from a modeling perspective.
Yeah, yeah. I would be in favor of, I mean, this is a case where we could model explicitly. You know, we could have an attribute that is, which if it is filled in, you know, we have an attribute called, you know, unreported. You said it meant, okay, if it was an empty value, it meant you specifically not reporting the information. So we could model that explicitly rather than relying on the syntactic, rather arbitrary syntactic convention. We can model it explicitly. So you could have in these facts, you could have a value and an unreported, and those are XORed. You either report a value or you say that non-reported is a flag turned on. And those are XORed. Yeah.
You brought an interesting, important point, which is not reported as different from being reported with nil. Victor has cases where they actually, he used the term hydrate once, where they actually distinguish facts that are absent in some manner. We can either do that in the formula link base by various means, or as one of Victor's projects did, they actually had a preprocessor that inserted something specific to say that this thing was absent from the submittal of this filing, and that's different. Being absent, which is really not reported, is different than being reported with something that states it's nil, whatever semantic nil might have. So that's maybe a fourth state that has to be the state of being absent is a possible state.
Yeah, this is healthy discussion. Yeah, I like it. Although I do want to be sensitive to time and our objective here. I think what this represents is that there's a little bit more fine-tuning that we still have to accomplish around the whole nillable and not reported aspect, and that's probably one of the topics for the upcoming AMPF calls. But for now, I think perhaps if we could get back to the topic at hand and consider the other portions of the model that we still need to go through, especially the concept model. The concept model is very semantically rich, and I do want to give sufficient time for exposure to that. So just before I dive into the concept model now, I guess I'm wrapping things up here on the instance side and on the fact side. Are there any further clarifying questions that I can answer at this point, or any other comments that the audience would like to make about the instance and the fact model that we've put together? Okay, good. Right, so what I'll dive into next is the concept model. And again, what I'll do is I'll just quickly show what the concept model looks like in its entirety in Magic Draw, and I'll just kind of quickly give you a sense of what is all on this particular diagram. And I've broken it down into three screenshots, and I'll be walking through them at this point now. So in our concept model, the real I guess the heart and the base of everything here is what we call the concept. So that's the class up here that's, again, italicized, indicating that it's abstract. And from it are derived two types of concepts. One is the item concept, and the other is the structured concept. So in a similar vein, as I described earlier with regards to the instance model, the structured concept is, again, AKA your tuple. And in our concept model, concepts essentially live inside of a concept container, and concept containers have the ability to export themselves and to import others. So this is the notion where if somebody was developing their taxonomy in different modules, and you were using X-link mechanisms, for example, to import other modules, then that facility is abstracted here. As far as the tuple concept or the structured concept is concerned, one thing that we've modeled in our abstract model, which is maybe somewhat of a departure than how tuples are generally interpreted in XBRL, is that we have this class that we've identified as being a relationship class, and in the next diagram you'll see how the relationship class serves as a key component of taxonomy extensions and the whole prohibition and overriding mechanisms that XBRL allows. But as far as a relationship is concerned, in our model, a relationship is simply between a single source and a single target. And we did this because we felt that simplifying how relationships worked as compared to how XLink works right now was an important abstraction that we wanted to bring to the table, which is that with XLink, as you might be aware, the ones that are on this side of the diagram here could actually be 0 to many, and your arcs can, or your locators can actually, is it your arcs or your locators that can point to multiple sources and targets? But nonetheless, in our model, it's only a single source and a single target. And having this relationship class in our model served as a good anchor point for what we introduced as a structuring relationship. So in tuples, you obviously can have a sequence, you can have an all, or you can have a choice. And what we've done with regards to capturing that semantically is by saying that a structured concept derives off of concept, and it has a structuring relationship with other concepts. And I left it out in my screenshot, but here there's a structuring kind, which we call the record union and sequence. And so this property here that we've introduced, structuring kind, is really meant to reflect the sequence and all, or the choice, and also the actual relationship between the tuple container and its children. There's a min and max occurs in terms of how many there are in that particular relationship. So that was there was quite a lot of discussion about how tuples needed to be brought into the fold, as it were, where the whole XLink mechanism and how relationships are handled. It was felt that tuples really needed to be classified in a very similar manner, and that's why you'll see that even though it's upside down here, there's an inheritance arrow from relationship to structuring relationship, which means that the way that tuples are thought of in our model is that they really are just a special kind of relationship that is being defined at the concept level. So the other thing to bear in mind too is that when you declare a concept in our concept model, the most likely intent is that eventually the concepts will be realized by a specific fact, and that's why we have the yellow box sitting side by side with the concept. Okay.
Do you want questions held till the end, or done slide by slide?
Well, I was thinking of taking them slide by slide, just because it gives proper context to the question. So, sure, if you've got a question, fire away.
Yes. The structure concept, I would expect that the structure box would have a little loop to itself, because certainly in the composition of tuples, which I think also applies to the composition of type dimensions and of reference parts, so I think you can reuse that same thing. The structure is liable to be a choice which nests some sequences, which may nest some further choices or sequences or alls. It's normally a graph structure that composes some kind of a content model, and not something flat that has a single structure concept with just a single sequence or choice or whatever.
Well,
it's a complex nesting.
So it may not be obvious, but that loop that you just referred to is actually in this diagram. So the way it works is that because structured concept is deriving off of concept, if you follow this relationship along this way like that, it is actually a loop in that.
But there's no concept in that case. The types nest themselves as anonymous types without exposing any. A concept is a top-level XML element, XML element, but an anonymous type nests itself without ever creating concepts, the same being true for reference parts or type dimensions.
Yeah, so I think the best way to show you how that would work is I can show you an instance of the model that models nested tuples, and I can walk you through what
I don't think Herm's talking about nested tuples. I think he's talking about more complex content models, for example, where you've got a choice nested inside a sequence, nested inside a choice or whatever.
Thank you, Paul. That's what I meant.
Oh, that's what you're meaning. Oh, I see.
That's what I mean.
Oh, it's the complex content model. I see. Yep. Oh, okay.
Paul is my best ghostwriter.
Yeah. No, that's great. Right. Yeah. Well, I think right. In that case, then.
Well, it's something we should probably go into in detail offline.
Yeah, we should. We should talk about that.
The target relationship, the concept, that can be a structured concept, because structured concept isn't, and any one of those structured concepts can be a choice, a sequence, can be a record, a union, or a sequence. Now, a union is basically a choice, so it can be so there are. So I think you can nest those things. I think the model support that could be missing something here. So we probably They're nested as types. They're nested without becoming new elements.
Yeah.
So that's an important distinction.
You're talking about what you want it to support anonymous types. You're not saying you want it to support anonymous types.
Yeah, exactly.
Absolutely.
Yeah.
Mm-hmm.
But I want the same typing model to support type dimensions and reference parts, which are in the base spec, or which are in the specs that you are now implementing.
Hey, Herm, could you, offline, could you send me an example of that, and then we can use that as the basis for one of our AMTF calls coming up?
Okay.
Okay, thanks for that. Okay. Any other questions at this point? Otherwise, I'll move on to part 2 of the discussion of the concept model. Okay. So in this particular snippet that I've taken, what I've tried to highlight is an abstraction that we've introduced called toggle and filterable element. So toggle is something that's absolutely brand new. We know that the term toggle does not exist in any of the XBRL literature at this point, but after a lot of discussions and debate as to how taxonomy extensions work and how prohibitions and overrides and base sets and how all that mechanism comes together, it was the conclusion of the task force that effectively all of that stuff comes together to form what we call a toggle. And a toggle has the ability to turn something on, turn something off. It's really as simplistic as that. And toggles apply themselves to what we call a filterable element. And depending upon which toggle wins, so you'll see in this in the association between the filterable element and the toggle, you can see that there's a 0 to many toggles that might be acting on that filterable element. The toggle with essentially the highest priority becomes the winning toggle, and that toggle, whether it's on or off, determines whether or not a filterable element is effective. So what we are essentially capturing here with these two classes between toggle and filterable element is the XBRL ability to do prohibitions. So that's obviously turning something off, and then overriding that to essentially turn something back on through the taxonomy extension mechanism. And anything that derives off of filterable element can essentially, in our model, be turned on and off. if you apply the right sequence of toggles. And deriving off a filterable element is a class that we've called filterable relationship, and I'll go into that in a minute. But there's also other classes that derive off of filterable element as well. So maybe it's most effective if I just bring up the entire diagram here and see if I can scroll everything onto the screen here.
Do you have facets on the, is facets on this model somewhere? Because I'm thinking toggle, the whole idea of toggle would be used to affect things like facets, particularly enumerations.
No, we don't. If facets, no, we don't.
Where would you have enumerations, for example? Particularly if enumerations were used as a source of relationships in generic models.
Enumerations, as in a list of concepts, or
no. Enumerations as an XML facet, which is in the typing model. Those aren't concepts.
Right.
But they are usable as sources of generic relationships.
Yeah.
So this would be a list of allowed values for a token or string or numeric fact.
Yeah, that's more at the typing level. That's not something that we would be necessarily turning on and off at the toggling level.
But it has this. All of the facets have the same have this toggle behavior in the manner you described, where they can be redefined and extended or restricted and so forth.
When we look at the typing model, you'll see, I mean, the XML, the kinds of things you can do with facets are all supported. There's, and the facets are, there's quite a number of different, kinds of facets. There's, for a numeric type, there's like total digits and the minimum, the minimum inclusive, minimum exclusive, etc. We have all that stuff in the typing model. The toggle was there to essentially abstract what was being done with the prohibition and override.
And do you mean by that the restriction on an element? Because you were on the concept page.
No.
Oh, you mean in the relationship model instead?
That's right. Yes.
Oh, okay.
Yes. That's right.
So in that case, you mean that the model includes tracking of ineffective relationships, such as required by IFRS and US GAAP?
Yeah. Exactly. So our model, if a relationship had been turned off, our model can retain that. Yes.
Okay, that's good. That is required for those two.
Okay.
The is effective derived property, which we had something similar in the secondary model. We wrote the rules for out in OCL, but if we have a to-do thing over the next few weeks to write the rules for is effective that just essentially writes out, okay, how are different toggles that are competing resolved based on the priorities.
So in this model, do you have, we have properties on the fact model, and certainly relationships can have a number of predefined properties, and of course it's completely legal for people to provide custom extensions to all the standard archetypes, for example, to add more properties. Where would those go in the model?
So those custom attributes come from the extensible element. So
no, relationship, extensible relationship, arc elements. If an arc element is extended to place more properties on an arc, on a relationship, not on a concept.
So the effective equivalent of an arc in XLink has been abstracted into the relationship class that we have here. So relationship is really the combination of your arc and your locators. And relationship, because it derives off of extensible element, has the ability for you to add user-defined properties to it.
great.
Okay, so yes, so I thought I'd bring this up here because part 3 of my discussion around the concept model was really all of these classes that are deriving off of filterable element. In the bottom right-hand corner here, you have your labels and your references, and essentially your labels and your references point to a concept. But because they also derive off of filterable element, your labels and your references participate in that whole overriding and prohibition mechanism through, that's implemented through taxonomic extensions. And so those two are toggleable, as we've been calling them. Likewise, we've it's somewhat of a multi-tier hierarchy that we've come up with in the middle of this diagram here, where filterable relationship is serving as your base. Off of that comes your item relationship, and your item relationship. Well, actually, these 2 lines need to actually go down here. Is the base class for your parent-child item relationship. So the parent-child item relationship is a specialized type of item relationship where your item concepts are your source and your target. So in one case, one plays a parent, the other one plays a child, and that's meant to add further restriction on this source and target that's up here, because this ultimately all derives off of the relationship class. So what this means is that all of these relationship classes down here, calculation, presentation, and definition, means that your sources and your targets can only be instances of item concept. So in other words, you can't point to a tuple in your calculation or your can you do that with presentation? I have to think about that one a little bit. But anyways, oh no, that's right. No, it's only calculation that's deriving off of parent-child. That's right. And presentation come off of this one, which means that your source and target could actually be tuples. I remember making that modification earlier on. That's why it started ringing the bell. Another relationship that we had identified that is more from the dimensions side of things is the primary item relationship. So essentially we have 2 relationships that are deriving off of the parent-child item relationship, calculation and the primary item. The other type of filterable element that we've introduced, or that we've captured in our model, is the class that we've called axis. Because we were using dimension, sometimes you get into the situation where it comes down to how you name things. But because in our instance model we had said that this is your dimension, we came up with a different. We had to come up with a different name for dimension in the concept model. We eventually settled on axis. Axis, there's 2 derived types of axes. There's a typed axis and an explicit axis. And in an explicit axis, there are 0 to many explicit members that belong within that axis. Now, I need to let the audience know that this particular portion of the model, between item concept and axis and explicit axis and member, the task force has actually been debating the completeness of this model in terms of being able to communicate hypercubes and specific combinations that are of axes that are allowed within that hypercube. And we do not yet have a conclusive decision yet in terms of how we want to model that. There's several options on the table, but in respect of Montreal and getting things ready for Montreal, we've decided to put that issue off on the side for now, and possibly even allow the public working draft feedback cycle to drive how we ultimately model hypercubes and restrictions of axis combinations that are allowed within that hypercube. Now, the model will be going public with that note in there. So as advance notification, if there are specific ideas or opinions as to how you, the audience, would like to see this model, we certainly are very open to your feedback and your opinion at this point with regards to that particular topic.
One point you said this was just for explicit access. The same discussion of the evolving in that area should apply to typed axes as well as explicit.
Right. Okay. Okay.
Ray, I have to leave in a minute, but there's,
Yeah, go ahead, Dave.
There's one thing that I want to point out about this, about the filterable element. Could you scroll up a little bit, please? So we've discussed one aspect of filterable element, which is the fact that toggles can be applied to it, and then the filterable element has the derived property that we'll be writing the rules for how the competing toggles are resolved. But I want to talk about the other property, role. In reference to some previous questions you've sent to the task force mailing list and discussed on mentioned on the call term, that role property in filterable element is really the abstraction of the extended length role. So the filterable element also has that property that you can use to just the arc role is abstracted here just by the different kinds of relationships, or the different subtypes of relationships make that distinction that the arc role makes in the XBRL syntax. But the extended link role, that's that role property. All the filterable elements have the role property, which is essentially functions as the extended link role in XBRL syntax today.
Yeah, we'll have to take that offline. I don't see how that solves the IFRS or US GAAP issue, but that's for later. Maybe after Montreal.
That's separate from the toggle. That's separate from the toggle. The toggling, it has nothing to do with the toggle. That's just the extended link role.
Yeah, I see it's an attribute, but I think it would have to be hung in the place where Warwick proposed it to do what we need. But that's
okay,
for
we'll
later.
talk about it. Yeah. Okay, sure.
Not now.
Sure.
Okay. The only other model that I haven't discussed yet, and I'm not going to spend a whole lot of time on discussing it because I think it's relatively straightforward and it was a fairly mechanical exercise to come up with the typing model.
Sorry, just before we do that, can I just throw another couple of questions on the previous model, the concept model?
Sure. Yeah.
What's the principal and inherited relationships between item concept and axis?
So Paul, is it this this specific association that you're speaking of here? Paul, when you said inherited axis, is this what you were referring to?
Yeah, that was the two different relationships between item concept and axis.
Okay, yeah. So in trying to figure out how item concepts were related to their axes, the dimensions specification allows for inheritance between primary items and their kids. And so if one is if there's a primary item and then it has a child, that the child also inherits all of the axes that its parent has as well. And so what we wanted to capture in our model is that, let's say that this was the kid concept. The child concept essentially has what we labeled a principal axis. So this is the set of axes that are explicitly bound to this particular item concept. But at the same time, if it was participating in a primary item inheritance relationship, it would also essentially inherit all of the axes that its parent had as well. And hence, in order to separate and to distinguish between the two different types of axes that are potentially associated with an item concept, we decided to capture it as two distinct associations to semantically separate the two of them.
So, I mean, I think I would probably argue that that is not an important difference semantically, because I've always considered that to be a bit of syntactic sugar for doing something in two different ways, somewhat unnecessarily. So, I would be inclined to just say to simplify that down to a single relationship.
Okay. Okay. I
think if you kept it, you would need to add a role attribute to that inherited relationship, which making it even more syntactic sugar complexity.
Yeah. Well, I think that's a fair comment. I can certainly see that would be one of the things that would be up for consideration in terms of a more simplified abstract model.
So if you had a prime.
Oh, sorry. Go ahead, Dave.
Just to understand what you're proposing. So if you have a primary item relationship like cost of goods sold, and one of them was one of them was sales travel costs, and what a child of cost of goods sold, then if you wanted sales. If you wanted, the one to have the access that the other one has, you'd have to state it. You'd have to assert twice that access, belongs to each of those primary items. You'd have to say it belongs to this one, associated with this one, and it's associated with this one. You'd have to explicitly state it twice, as opposed to saying, well, I can just rely on the fact that since there's a primary item relationship, it just inherits. It's logical. I mean, there is a logical relationship there. Just so you understand, I mean, I'm not necessarily opposed, but just so you understand the implication, and we're thinking about these are the abstractions that we would like to be able to present to people who are designing taxonomies, and give them simplified abstractions that are simple, hide a lot of syntax, yet are sufficiently expressive. They would have to assert that twice. Okay.
Well, in the syntax they can still say the same thing. The point is that we present a much simplified model, which is there's only one way of having an axis, and that's you have an axis. And the fact that you got it through inheritance rather than got it through an explicit relationship, from the point of view of the logical model, should be irrelevant.
Would you consider it a well-formed taxonomy if the axes didn't match? In other words, I logically should have have the same axis as this other item that I'm in a primary item relationship with, but the taxonomy designer neglected to make the assertion. Would you consider that an ill-formed taxonomy or a well-formed taxonomy?
That seems, yeah. If that's I think we have to rely on the information in the model being correct. So if that's what the model says, then that's what I'd understand, and I would then translate that into syntax which said that. Whereas, assuming it was all consistent, then I have a choice when translating it into syntax to make it all explicit, or to make it more concise by using inheritance. Although actually, I'm not sure it actually makes it any more concise in terms of the number of relationships you have.
But in inheritance, when the inheritee makes further specializations, which I guess you would be using the toggle stuff, I'm not sure how I see how that would be handled.
I mean, I see this as equivalent to what's been done with relationships, which I think is very positive, which is even if an arc defines multiple relationships, they get expanded out into separate relationships. I see it as exactly equivalent. It's syntactic sugar for doing something one way, and but it means the same thing.
Yeah.
We don't necessarily want to. One way of looking at this model is it's the abstract syntax. It's what you want to present to a taxonomy designer. You don't necessarily want to eliminate all syntactic sugar. If something syntactically is more compact, if there's something that is a more straightforward way to present the abstraction to a taxonomy designer, if it's more straightforward to them, that does not, in my view, does not disqualify it from the model. What we want to avoid certainly want to avoid arbitrary syntactic, very detailed syntactic stuff that's very oriented towards the machine, just like the thing of all the stuff that happens with prohibition and override and having to be in the same base, have equivalent relationships defined in order to know whether prohibition and override can happen. And we were able to boil that all down to really what you're just expressing is you want to turn a relationship on or you want to turn it off. And I'm totally, we have to do as much of that kind of stripping away of that, low-level syntax as possible. But it doesn't mean that anything that's just a syntactic convenience from the logical expressive standpoint for what you present to the taxonomy designer doesn't mean that you don't have any of that. You don't have the low-level stuff, but you might, if it's more straightforward, logically, to say to the taxonomy designer, if you've declared these relationships, these primary item relationships, okay, these things will be inherited. You don't have to go back and state them twice. If that is more a convenient and simple and straightforward way for the taxonomy designer to express it, I think I don't think that then we have to. It doesn't. It's up for consideration at least. And I realize the pros and cons, and I'm certainly open to talking about it. I understand the point you're making. But I just also wanted to throw that out as a. And we can discuss that design philosophy. Yeah.
I would say that if what you want to express in the model is that inheritance capabilities in the dimensions specification, what should be represented is the fact that a concept inherits the dimensional properties of another concept in a certain extended link role, rather than inheriting a specific dimension. That it seems to me that what this model represents. And another issue I see is that, for instance, the properties of open hypercube, I can see how that can be reflected in this model, because it seems that here you are explicitly enumerating a set of dimensions. But the idea of enumerating certain dimensions but leaving it open for additional dimensions, I can't see how can this be represented. I mean, certainly this is a topic that it's it's very hard to discuss.
Yeah, and we are over time at this point, and I think I do want to be sensitive to everyone's time. The only so I talked about part 3 and typing model. I quickly went through that. The only thing I wanted to wrap things up with is really everyone on the call are very experienced XBRL practitioners in one manner or another, and we do want to seek your input in terms of what you think should really be appropriate next steps for the model. We know that we have to polish off the model to eventually move the model to candidate recommendation and finally to recommendation. But some of the things that are on the table at this point is to deliver on the secondary model, as I alluded to earlier. There's also formula versioning, rendering, those 3 specifications, which potentially could also benefit from a round of abstract modeling as well. Right now, there's a comparability task force that's going on underway, and our abstract model is actually playing a role in that effort. There's a slot that's been set aside for where the model can play a role in it. And likewise, possibly with an upcoming API signature effort, I would anticipate that the abstract model would play a pretty leading role in that as well. There's also the application of the model in specific domains, so in IFRS or in US GAAP, and to facilitate that, maybe we might want to come up with a UML profile for XBRL so that tools and other automated systems can really leverage the model that we've delivered. So we do want to actually give some thought as to what you would think the most appropriate next steps would be for the abstract model. I know the XSB has this as being one of the topics that they need to discuss and provide some guidance on in terms of where they would like to see the model move ahead. But certainly your input will be tremendous guidance in helping the XSB make that upcoming decision as well. So I do want to thank everyone for your time, and we did send out that little introductory note in terms of where we would like to receive feedback specifically. So if you do want to answer those questions, those targeted questions, we do encourage you to do so. And if there's other comments and other questions that you have, feel free to email myself or to email the abstract or the modeling-feedback@xbrl.org email address that we mentioned earlier. So that's it for my portion of the presentation. And Tony, I don't know if you wanted to wrap things up at this point, or if there's other comments that you wanted to make to the group before we wrap that off.
Yeah, no, thank you. Again, I think you've covered the topic well. I mean, our goal here is to get some additional feedback before releasing this in Brussels. I think that the group, since the January face-to-face meeting, has been working, quite hard and having a lot of serious discussions about about bringing this model to the market. And I mean, we've hit some very interesting challenges in trying to model certain aspects of the specification and trying to accommodate what we know are some practices in the market, but really staying true to those initial goals that Ray put up, and that we really wanted to have a primary model that would be useful to the market. So I just encourage you to look at this material, think about it deeply, bring those comments back to Ray. I know that David has left the call, but I just wanted to let the group know how important David Frankel's contribution has been to this model. We've worked with a number of people from OMG. David Frankel is a real expert in the area of UML modeling, and I think now probably understands XBRL substantially better than he did when he came to us. And the people from No Magic that made the contribution of allowing us to use their product for the modeling effort have all been instrumental in kind of bringing us to where we are now. There is still work to do, but I know that the people on this call will give us their best input so that we can have a product to release to the market in Brussels. So, I mean in Brussels, in Montreal. So I appreciate very much the fact that each of you has agreed to take some of your time to look at this work product. I think it's very important for the market. So thank you again, and we look forward to your input. And I know that Ray is available to meet with you one-on-one as well, if that would help you kind of talk through some of the ideas that you have related to the model. So please reach out to us. I know we have a short turnaround time, but your input is very important to us. Thank you, Ray.
Thanks very much, everyone.
Thanks, Ray. Thanks, Tony. Thanks, everyone, for your participation.
Thank you. Bye.
Ray, are you still there?
Yeah, I'm still here.
Can you hit stop recording on your screen? If not, I need you to reshare your screen so I can hit stop recording before you stop sharing.
Oh, okay. Here's my screen again. I couldn't. Where do you do the stop recording?